You are most welcome. I'm Teacher Ivan from WUNNA Educational Services. Today we are looking at the A-level physics, paper 1, and we shall start with the section A of mechanics. And under mechanics, we are to begin with chapter 1, which is dimensions of a physical quantity. But before we look at dimensions of a physical quantity, please, I request that you subscribe to all our channels from WUNNA Educational Services. That is Teacher Ivan's online classes, WUNNA e-learning platform, and WUNNA Kids platform. Let us look at dimensions of a physical quantity. Dimensions of a physical quantity is defined as the way derived quantities are related to fundamental quantities of mass, time, and length. The way derived quantities are related to fundamental quantities of mass, time, and length. So, in our definition for dimensions of a physical quantity, we have two key terms, that is derived quantities and the fundamental quantities. So let us look at what derived quantities are and what are the fundamental quantities. So if we look at the fundamental quantities, these are physical quantities which cannot be expressed in terms of other physical quantities. For instance, we have mass, we have time, we have length, we have current, we have temperature, and so on. So all these quantities cannot be expressed in terms of other physical quantities. For instance, if I asked you, what is your mass? There is no formula you're going to use to get your mass apart from using an instrument to measure your mass. The same thing applies to time and other fundamental quantities. So these quantities cannot be expressed mathematically, cannot be obtained mathematically using other physical quantities. Those are fundamental quantities. Now we come to derived quantities. Derived quantities are defined as these physical quantities that can be expressed in terms of other physical quantities. For instance, if you look at density equals to mass over volume. That means that density is derived from mass and volume. If you look at pressure equals to force over area. So pressure is derived from force and area, among others. Therefore, we come back to our topic of the day, that is dimensions of a physical quantity. The way fundamental quantities are related to, the way derived quantities are related to fundamental quantities. How do we obtain dimensions of a physical quantity. For instance, let us look at dimensions of density. Dimensions of a quantity, let's say density, the dimensions of density, dimensions are represented by brackets. Dimensions of density will be given by the dimensions of mass over the dimensions of volume. And therefore, the dimensions of density will be, since mass is a fundamental quantity, its dimension is capital M. And volume is derived from length. Therefore, volume is length cubed. And therefore, the dimensions of density will be mass per cubic length. That is how we get dimensions of density. We can also look at the dimensions of pressure. We very well know that pressure is force over area. So, dimensions of pressure are given by dimensions of force over that of area. And this will be, force is measured in newtons, which is mass times acceleration. So the mass is capital M. Acceleration is given by velocity over time, and velocity is displacement over time. So that is length, because displacement is length, over time, that is velocity. But acceleration is velocity over time, so we say still over time to get acceleration. Over length, area is length squared. So that gives us the dimensions of pressure as mass, length per time squared over length squared. So when we apply the laws of indices, we come up with the dimensions of pressure as mass per length per time squared. So that is how we shall derive the dimensions of pressure. Now we have looked at dimensions of different quantities. What are the importances of dimensions to a physician? Dimensions are used in checking the validity or correctness of an equation. Still, dimensions can be used to derive equations. Those are the major two uses of dimensions. So, in our next lesson, we shall be looking at the uses of dimensions in checking the correctness of an equation, and also how we use dimensions to derive an equation. See you next time.